All right, so another example here. Going to follow that one up with another circuit, but slightly different. In this case, instead of a current source, I'm going to put a voltage source here. And then instead of connecting two resistors the way I had them previously, I'm going to go ahead and connect them like this. Okay? And I'm going to go ahead and throw ground here. And we're going to go ahead and analyze this circuit. Let's call this a 1K ohm resistor, and this will be a 2 kilo ohm resistor. And I'll just make this a 24 volt voltage source. All right. And so what I want to do is I want to find I1 and I2 in this circuit. Okay. And so this is a little bit different from the previous case. In the previous case, we were looking for node voltages. Here, we'll call this VA, and we'll also want to solve for that. But that by this time, that should be pretty obvious. But in the previous circuit, we were trying to solve for node voltages, given that we had a current source. This time, we're trying to find currents through our resistors, given that we have a voltage source. Okay, so the analysis is going to be a little bit different, but nonetheless, honestly, in this case, probably a lot easier. And we are going to use Ohm's law like always. So let me just write it up here. V is equal to I times R. Just make a block there. Also, let me just write the other version of that, which is if I divide both sides by R, I get that I is equal to V over R, right? Which is useful in this case because we're actually trying to find currents, okay? But it's important to remember this V is the voltage across the resistors. Okay, so just keep that in mind. So if I go ahead and analyze this, I know right off the bat I have two nodes in this circuit. So I'll go ahead and highlight those. My first node is this VA node. I'll highlight it in yellow. Oh, that's a little thick. Let's go with this one. VA node, I'll highlight in yellow. And I have one other node, which is my ground node, which I'll highlight in green. And what's my node voltage of my ground node? Of course, we know that by now should be pretty self-explanatory, 0 volts, right? So if I know that this is 0 volts and I know that my battery is rated for 24 volts, I should be able to very quickly determine that VA is just going to be 24 volts because I know that my plus side of my battery, our voltage source, has to be 24 volts higher than my minus side, okay? So now we know the voltage across both resistors, right? We know that this resistor has 24 volts here and 0 volts here. We know that this resistor has 24 volts here and 0 volts here. And so we can very easily solve for the currents just by using Ohm's law. So let's just look at this one first. I'll go ahead and draw it like I normally do. I'm sorry, let's go black. If I have my resistor, I know I have 24 volts here, 0 volts here, 2 kilo ohms, and I'm trying to find I2 in this case. I should just be able to use Ohm's law. I2 is going to be equal to V over R. Again, remember that V is the difference across my resistor, which is 24 minus 0, or 24 volts. So I can write that it's 24 volts divided by R, which is 2 kilo ohms in this case. And if I do 24 volts divided by 2 kilo ohms, that's going to give me 12 milliamps of current for I2, okay? So I can go ahead and put a box here. And I've determined I2. Now using a very, very similar process, I can solve I1. Instead of saying similar, I should just say identical. It is the exact same process. So if I pull R1 out, again, pulling these resistors out is not, it's not necessary. You could just look at the circuit and just solve it. But I just like to draw it separately just so you realize that what we're doing every time is we're analyzing the node voltages and the current through that particular resistor. I think it just breaks the problem up pretty nicely. But it's important to recognize that it's not necessary to do this. I could just analyze it directly on the circuit schematic or the diagram. So in this case, I'm trying to find I1. I know I have a 1 kilo ohm resistor. And using Ohm's law, again, my voltage drop across here is 24 volts. I can say that I1 is equal to V over R, which in this case is 24 volts over 1 kilo ohm, and that's going to be 24 milliamps. All right, go ahead and put a box around that. And we're done with this problem. We found VA up here. We found I1 and we found I2. And that is another example. Let me just go ahead and move all this stuff more, maybe make it more central so that it looks nicer when I export. Yeah, we went ahead and used Ohm's law, solved another circuit with more elements. And the next section here, I'm going to talk a little bit more about multiple element circuits and what we're going to do next.